Welcome everybody to this chapter review video. Remember, you are always encouraged for chapter review videos to first review the individual sections on your own first. Make sure you understand the basic content. How does it all stitch together? What are the relevant formulas? Do you have those close at hand? Do you have your calculator? Then begin this video. At each point, pause the video and attempt it on your own. You need to get feedback about if you know how to solve the problem or not. So attempt the problem. If you don't know which formula, look through your notes. Use this as an opportunity to practice gathering that information. Unpause the video, check your work. Continue with the next problem after that. So we saw the table that I've now shown on the screen in this section of notes. This table is helpful to visualize because it helps us make sense of what is a type 1 and what is a type 2 error, and what does that mean in terms of what was true and what do we actually end up deciding for a hypothesis test. Remember, when we're talking about a type 1 or type 2 error, that means the conclusion ran for the hypothesis test was actually wrong. Okay? We might have concluded correctly based on our test statistic and our p-value or critical value. However, it's not representing reality because remember, this is just an approximation based on data at a certain level of significance. So with that, what's going on here is we've got a company that manufactures steel wires. It says the mean breaking strength of the wires is greater than 50. That's what they want to guarantee. They measure the strengths for a sample of wires, and we run the hypothesis test that the mean breaking strength mu is 50 versus the alternate hypothesis that it's greater than 50. And here I notice I have a typo. I accidentally wrote 504. This should of course also be 50. If that error is also on your paper, correct that to 50. Okay. If a type 1 error is made, so we ran the test, we concluded correctly based on the test, but it turns out it's not correctly representing reality. In fact, we have a type 1 error. Well, look in the chart. This is where a type 1 error is. It's from the fact that H0 is true, column, but it's in the reject H0 row. So what happened is, at the end of this hypothesis test, we rejected H0. We said H0 is not true. However, this was an error because since it's a type 1 error, we see, but H0 was actually true. That is a type 1 error. It said, if we made the type 1 error, what would have been our conclusion that we drew after the hypothesis test? Well, our conclusion would have been to reject H0, and when you reject H0, then you assume H1 is true. So my conclusion would have been that the mean breaking strength, because that's what we're interested in, mean breaking strength, of the wires is greater than 50. So if we had made a type 1 error, this would have been our conclusion, and it would have actually been not reflecting reality, even though we did the process correctly. Now, if instead a type 2 error is made, we can see in the table, a type 2 error will only occur if you have a false H0, so it's actually a false H0 value, but you end up not rejecting H0. Okay. Now remember, when you don't reject H0, all we can say is there's not enough evidence to conclude what we wanted to determine. So if I was to state my conclusion that resulted in a type 2 error, I would not reject H0, so I would make the conclusion that when you don't reject or you fail to reject, you always start with the phrase, there is not sufficient evidence to conclude that the mean breaking strength is greater than 50, because in a type 2 error, we failed to reject even though H0 was false. I would encourage you to pause the video now and attempt our next problem. Unpause to check your work. So we know in this chapter that deals with hypothesis tests, we've got the idea of a hypothesis test that we apply, but we just apply it in a variety of situations. And for the different situations, we have a different process. So our first step is to identify which one of these do I fall into. First is a hypothesis test for a mean value. If so, you then winnow it down to, well, is it for standard deviation known or standard deviation unknown? Or is it a hypothesis test for a population proportion? So let's read through and see which is the case here, because that will direct our steps in how we solve the problem. Our survey sampled 1923 people in Colorado and asked them how long it took to commute to work each day. The sample mean one-way commute time was 24.5 minutes with a standard deviation of 13 minutes. Okay, now this is very important. It says the sample mean was 24.5, but then the sentence continues and said the sample had a standard deviation of 13.0. So even though it didn't write out S is equal to 13.0, by the phrasing, I know this is a sample standard deviation as opposed to a population standard deviation. That single sentence is what tells us which method to use. We need to go through the hypothesis test for a mean with standard deviation unknown. And when I say standard deviation is unknown, I of course mean the population standard deviation is unknown. So a transport engineer claims the mean commute time is actually less than 25 minutes. Does the data provide convincing evidence that the engineer's claim is true? Use the alpha equals 0.05 level of significance. So first, you always state your null hypothesis, your alternate hypothesis. Now, the thing that we want to prove is that the mean commute, mu, is less than 25. We want to show mu is less than 25. What is H naught? It's always mu equal to the value. So here we have mu equals 25. Now, for this case, let us use the critical value method, and you can look back in your notes to find the critical value method. In the critical value method, whenever I'm dealing with standard deviation unknown, I need to use my student t-distribution chart, which means I need my degrees of freedom. The degrees of freedom is the sample size minus 1, that is 1922. I've got an alpha of 0.05 level of significance. Let's bring up the chart, and that will tell me my t alpha over 2 value. Now, one thing to take note is this is a left-hand test. So in my left-hand test, left-tailed, this is where my t alpha over 2 value is. I need to find that. And as alpha is 0.05, I know this area here accounts for 0.05. Okay. So here, if I know that the table right now is showing me area in the right of the tail, but keep in mind area in the right is symmetric to area in the left because our t values are symmetric. This is the negative value, this is the positive. So what matters is if I was looking at the positive t value, the positive version, this would also have an area of 0.05, so I can use this value, okay, and just apply a negative to it. So here, the amount in the tail is 0.05. Degrees of freedom 1922, you go way down the list and you see that critical value is 1.645. So that's negative for the left-hand side, positive for the right. And since I'm dealing with a left-tailed test, I'm interested in this negative critical value. Now, if you look at the hypothesis test, it says, okay, you're going to reject it if your test statistic is actually less than this value. But I can't know that until I calculate my test statistic. My test statistic here from the formula is t is x bar minus mu naught divided by the sample standard deviation divided by the square root of n. Let's highlight what we know. We know x bar is 24.5. We know our mu naught is the level that we're measuring off of, 25. My sample standard deviation is 13. And my sample size is 1923. So that would be 24.5 minus 25 divided by 13 divided by the square root, 1923. Now we'll want to compare these. This is to 3 decimals, so I'll round this to 3 decimals, type it into your calculator. When rounded, you get negative 1.687. Now here we need to know, how would negative 1.687, would it be to the left of negative 1.645, which is less than that value, or would it be to the right? Well, this is a further negative number. It's further away from 0. So it would be over here in this portion of the tail. So our conclusion is, it says if your test statistic is in this portion of the tail, then you reject H naught. So as my test statistic t, negative 1.687, is less than or equal to my critical value t alpha over 2 of negative 1.645 for my left-tailed test, the conclusion for the critical value method is reject H naught. Now, keep in mind we're almost done with the problem, but once we reject H naught, we then have to write out our conclusion in context. So we can just say we can conclude we rejected H naught. That means we can conclude this is true. We can conclude mu, which represents the mean commute, is less than 25 minutes. And that would be our conclusion to this hypothesis test. So if you would, pause the video, attempt this next example, unpause to check your work. So we have one study found 71.8% of all emails sent as spam. A system manager at a large corporation believes the percentage at his particular company may be 80%. In order to test this, he examines a random sample of 500 emails and finds that of those 500, 382 are spam. So what we see here in this phrasing is he took a sample and he recorded information about the sample. That sounds a lot like a proportion for the population. Using alpha, level of significance 0.01, can you conclude the percentage, remember percentage is just a different idea of proportion of emails that are spam, differs from the 80%. So here I can see I'm doing a hypothesis test because I'm trying to test a claim. But we know hypothesis test has 3 categories in our class. Hypothesis test for population, standard deviation known, hypothesis test for mean, standard deviation unknown, and hypothesis test for population proportion. Based on this phrasing, the fact that we took the sample and we're seeing is this sample showing us information about an overall percentage, a proportion, we know we'll do hypothesis tests with population proportion. And for this example, let's use the critical value method. Now we first need to write out what is your null hypothesis, what is your alternate hypothesis. Remember, your alternate hypothesis is what you're trying to show. We want to show that the spam percentage, the population, the proportion, differs from 80%. Well, as a percent needs to be changed to our proportion value of 0.80, and we're curious to see if the population proportion is different, not equal to 0.80. Okay? Now, our null hypothesis is that it is the same as 0.80. Write that out first. This is always your first step. And now for population proportion, I need the value p hat, which is your sample proportion, which is 382 out of the 500. And we've got, for the critical value method, if you look back in your notes, you'll find this chart that gives you your critical value based on whether your test is two-tailed, right-tailed, left-tailed for a few different significance levels. Now, nicely for us, our alpha of 0.01 is one of the given significance levels. I can see that this is two-tailed because it's not equal to. So that's this section. Where do both of those intersect? At plus or minus 2.576. Let me just draw a quick sketch of our normal curve here. So I've got my negative 2.576, my positive 2.576. And if you look through the rules for the critical value method, it says you need to find your test statistic. The test statistic in this case is z, which is p hat minus p naught divided by the square root of p naught times 1 minus p naught divided by n. Filling in this information, n is 500. We've already found p hat, and our p naught is the value that we're measuring it against. So writing this out, we've got 382 divided by 500 minus 0.80 divided by the square root of 0.80 times 1 minus 0.80 divided by 500. Now we will type this into the calculator, and let's round to, since this has 3 decimals, we want to compare them correctly. I'll need to round this next one to 3 decimals. And we get a z-score of about negative 2.012. Now where is negative 2.012? It is in this middle section. It's closer to 0 than negative 2.576. Now, if you look at the criteria for when you reject or fail to reject for the critical value method in this case, it says you fail to reject if it lies in this region. We can only reject H naught if I either lie before the test statistic or after the test statistic. If I'm in between, the critical values, if my test statistic is in between the critical values, this is when I fail to reject. So here I would say as my test statistic z, negative 2.012, is not less than my z alpha over 2 value of negative 2.576. Because of that, I fail to reject H naught. And then I do need to make the correct conclusion. If we fail to reject, that means we always start with the phrase, there is not sufficient evidence to conclude, and then whatever we were trying to prove. So I have, there is not sufficient evidence to conclude. Okay, and what were we trying to show? That the percentage of emails was different than 80%. Emails that are spam differs from 80%. So in this next example, pause the video, read through it, attempt it on your own, unpause to check your work. So here I have a study conducted in 2015 by a technology company showed the mean time spent per day browsing a video streaming service for something to watch was 19.3 minutes. Assume the standard deviation is sigma equals 8. Now really quick here, if they're telling me sigma is 8, sigma being 8 is the population standard deviation. So we're interested in things about the mean, but I know the population standard deviation, so this is going to be the process of mean with standard deviation known. Pick up on those context clues because it tells you which process to use. Okay, continuing where we left off. Suppose a simple random sample of 100 visits. So here I've got my n is 100. Sample mean is 21.5, excuse me. A social scientist is interested to know whether the mean time has increased. Well, has it increased from the previous value of 19.3? So in this case, we've got our hypothesis test. We'd like to know if the mean value has increased, is now greater than 19.3. And then our null hypothesis is that it's the same. Always null is that it's the same. For this problem, we're doing hypothesis test because we're trying to test a statement, and we're interested for the mean when we know the population standard deviation. And in this case, let's do our p-value method. So in the p-value method, I'm first recognizing this is a right-tailed test. I'm going to draw my quick sketch of the situation. Here's my right tail. And in the p-value method, we can directly find z x bar minus mu naught divided by sigma divided by square root of n. Go to the right section of your notes, you'll find this formula. Plug in what we know. X bar is 21.5. Our mu naught is the measure that we're measuring against, 19.3. Divided by population standard deviation of 8 divided by the square root of 100. This is 2.75. And that 2.75 is the z-score here. Now, in this normal chart, our idea is for a right-tailed test. This is right-tailed. You've got to look at your notes. You'll see this description. For a right-tailed test, if the area to the right here is less than our alpha of 0.05 level of significance, then we can reject it. But how do I know the area here? I've got to go to my cumulative normal distribution chart. Now keep in mind, the cumulative normal distribution chart actually gives you this information. But you can then say 1 minus that to get what we're looking for. So let's go to our chart. And we're interested for the z-score of 2.75. So I'll zoom out a little bit. 2.7 is this row. 0.05 is this column. That gets me 0.9970 is the amount of area to the left of 2.75. But that means the amount to the right is 1 minus 0.9970, which is, if you type this into your calculator, 0.003. Now in the p-value method, this area to the right, since I'm in the right-tailed test, I need to compare that to my alpha of 0.05 level. It's actually less than that level. And if it's less than that level, then our conclusion is that we reject H naught. Now, if we reject H naught, how do I make my conclusion? It says we can conclude that what we were trying to show is true. Mu is the mean time browsing the site. Is greater or has increased. We could use that phrasing from above. So remember, if you'd like more detailed instruction for any of these topics or methods, look in the timestamps of this video and you'll see which section each problem came from. Go back to that specific section video and watch it. Then you'll get detailed step-by-step and a little bit of a slower pace, because remember, this is a review. As always, if you have questions, feel free to reach out to me via our campus communication, and I'll be very happy to help you.